again, it's Cliff here from Down Under. In this video I'll be talking about work holding using fixtures. You can probably see in the background there a 8-part fixture. I'll go through making that. I'll be using this mechanical tool setter. I've recently done some videos on tool setters if you're interested, and but this will be mainly about making a fixture and using a fixture for production. If you're thinking about making your own fixture, you can design and make a custom fixture like this fixture, or you can look online to see what's available from the fixture suppliers who sell modular fixtures that you may be able to machine your part shape into. And it's worth having a look online at those, even if you are going to build a modular custom made fixture for yourself, because it may give you some good ideas. So there's the fixture mounted on the table with 2 cap screws and T-nuts, and you can see the parts are held in with these tapered washers and located in these pockets and located in a rotational position with a pin or a drill each time it's tightened up. So that's working really well. I won't go into setting up and running this part and this fixture, because you may have seen the companion video, multiple parts using work offsets, subroutines and sequential serial numbers. These parts have sequential serial numbers, and that's quite an interesting side issue that I go into in that video. But this video is about using fixtures to hold multiple parts. So obviously one of the big advantages with fixtures is that you spend one block of time removing and putting in the new parts for the production run, which is more efficient because you've got all the tools in your hand and you're cleaning them all together and screwing them all in together in one block of time, and then it runs for much longer, for 8 times longer, while you go away and do something else. And for a serious amount of time this will run, because it's a low RPM spindle, 5140 RPM, and I'm doing a very small engraving. I could fit a high-speed spindle and do it much quicker, but really, because it runs automatically for a decent amount of time, I can go away and run another machine anyway. So I don't really see the need for that. As long as it's not tying up your own personal labor time, the cycle time is not such a big deal. You can engrave with low RPM. It doesn't hurt the job or the tool. It just needs slower feed rates. So that sort of wraps up this video on fixturing. Have a look at the other video if you're interested in the setup details of using different work offsets and subroutines within the G-code, so that I've only got one piece of toolpath, and the subroutines take it through the different work offsets. While we're on the subject of fixtures and the nomenclature of work holding, as far as I understand it, a fixture is for holding work or parts, and a jig is for holding work and guiding the tool. So if you're trying to work out whether to call something or a jig or a fixture, that should help. And with 8 off per cycle, you very soon can produce lots of parts. Like the design or the principle of a mechanical tool setter, let's call it an MTS, not an ETS. You just come down on the pad, come down to 0, click the last little bit, and then come over to your software, and this is tool number 10, touch 0, just touch that button, it's all you do. And then here we are, 63.73 is automatically loaded into the tool table. It's just so quick, and I can go through and set up my other tools. This is a very cheap little mechanical MTS. I like the look of it, but it has got a fault, a couple of faults, and I may do a more thorough review of it. It doesn't repeat 100%. There's a fault in the connection between the dial indicator part and the plunger part, and it's a quality of manufacture fault and also a design fault. So I'm not sure that you can fix it 100%, but you know, it's within a thou or so of variation, which is disappointing, and I've been thinking of a way of making an improved design MTS. I made a video recently on this mechanical tool setter, or MTS. I'm not sure if I've published it when this video's out, but I like the design principle of it. So you have a straight edge that straddles those 3 buttons, and that is set to 0. So that those 3 buttons are producing a 0 surface when the middle plunger is on 0 on the dial, and that means that you can set your probe length off that button, because I can go here on the probe setup page into tool 99, move and set probe length. Let's do that again. And what that does is install automatically in the offsets page under tool 99 102.66 as the probe length. Well, that's really easy. So now if I want to set a tool, so I've established the relationship between the tool setter position and the probe. Now if I want to set my tools up using that MTS, well, let's just go through doing that as an example. So I've got my 10mm carbide tool in there. I've set tool 10 in the tool table, and I come down until we strike 0. Now at that position, on the tool offsets page, we just have to touch that Z button and it loads the tool length automatically here, 75.40. So it's really fast and easy. I don't know that there's much advantage in having an ETS, an electronic tool setter, over a MTS like this, because your process is very quick and automated anyway. You're just pushing that one button when the dial indicator is on 0. What I like about it is it's much safer. With an ETS, you're coming down with an automatic probing system with the head coming down. It's a carbide cutter in there coming in contact and hoping that everything works electrically and you've connected it up properly. If you haven't, you've made a mistake. Well, it's coming down under power, and probably before you can react, it will have done some damage. You know, it could break the cutter or the ETS, or the spindle bearings, or the ball screw, the Z ball screw and ball nut, and so on. Now, I know that that's unlikely, and that plenty of people have got ETSs and they work fine for them, but I'm just a bit nervous about it long term with cutting oil and electrical connections and things, that sooner or later I might push the button and just watch it crash before I can do anything. I'd like to make an impact tolerant version of an ETS, and I've started designing one, But really, it's so quick to do via this method by just manually touching off each tool that I don't know if there's a big market for it. In the meantime, I'm happy with this little mechanical ETS. There's a wee bit of an issue with it. It's a cheap copy of probably a better quality design. The vertical plunger is a separate mechanical component from the dial indicator, and the connection between the two is not very well done. It's quite poorly connected, and so I'm getting a variation due to that connection of around about 1/1000 or 2/100ths of a millimeter. So it's a sort of an inherent error, and it would be very difficult for me to fix this because the design, the problem is largely a design problem. So I was thinking of making another mechanical tool setter. So that's a possible product, or just making one for the interest of it for myself. Let me know if you're interested in such a product, a more accurate mechanical tool setter, or if you know of where you can source a more accurate mechanical tool setter than this little Chinese knockoff. It's kind of 99% right, but not 100% right. But please let me know in the comments below. Put in a link to where I can buy one, because I'm seriously considering an improved version of this because I like the idea of it. Well, let's do it again. I've put in a drill now, a 5mm drill. So it's good to do a couple of examples here while I'm talking. So I'll put in 5 here, tool 5, enter. So it's highlighted it there, tool 5. That's the previous length of 56.64mm. So now I'm going to come down. This is how easy it is. And that set the drill to 0, the same height that we've probed off. Come in here, and we're just going to touch Z, and it'll update that tool length. Where are we? Here we are. And we're now 113.03. So we've set the drill as quick as that, tool number 5. So I'll just go through and put the tools in for this particular program, and then we're ready to run. What was I going to say? Yeah, let me know your thoughts on this. I know a few people have got electronic tool setters. Have you had a crash? Are you worried that it's damaged your machine? You can get a backup circuit in an electronic tool setter that switches the machine off if the first switch doesn't work. So there's another switch that goes through and triggers your e-stop, for example. But that would be 2 circuits to be wired in, and you know, you'd probably want to install your ETS permanently on the table. Then you've got coolant spraying around everywhere. How reliable is that going to be long term? Is it going to be erratic? Is it going to get in the way? Is it going to get covered in chips? You know, there'll be people out there that have done that. Please post in the comments below if it's working for you or if you have any problems, because I'm really looking at the different options here for a tool setter. A smaller drill now, 3.2 drill. We're calling that tool 4. Enter. Brings up tool 4. Was 115. Come down. This just strikes me as safer. It's only rough for a drill. There. Come up to here. Where's my mouse pointer? Press the button, and now there we are, set it in there, 82.767. So you can see how fast that is and safe that is. You're coming down, you've got your hands on the controller. It's just safe. And finally, a chamfer tool, tool 15. Highlighted tool 15. Leave offset 0. That's a previous idea I had. Alright, so we just come down here. There's two turns of the small dial before you hit the reference 0. It's a bit like a hammer, it gives you a few seconds. There we are. Come up here, click, touch Z, and it installs it. 76.339. As fast as that, I've set 4 tools and I'm ready to run the part. Well, you saw I had the mechanical tool setter set on the back of the vise. I think that's a better position than on this part of the jaw, because this part of the jaw moves up and down when you tighten it. It's got clearance on it and it's not a precision level surface. But it doesn't really matter where you put this, because all you're doing, it doesn't need to know where the table is. All you're doing is you're setting the relationship between the probe and the tools, and you're using this dial indicator, effectively the mechanical tool setter, to dial in that 0 position, which fixes the relationship between the tools and the probe. So now we've got that done in the tool table. The probe and the tools are all tied up. So now when we probe the work, we set the work offset, and now the software knows where the work is. Let's just do that. So we're going to go to XYZ probe, probe Z, set work origin, put tool number 99 in the DRO down the bottom there, and up here we're just going to go probe Z, set work origin. Now the software knows where the work is, and that's relative to the tool lengths. So now if we go to this page, we can go find the center. So now we can set the software up to the work offsets in the X and the Y. So here now they've changed this, find center and set origin, or display results only. It's a slightly different way of doing it. So we're going to leave it at set origin. We're just going to click on there, find center. See if I can do this while I'm holding the camera. It'll be interesting. So we're going to do the X, find center. We're just going to put a parallel on the end there, and one end. You can set the speed of the probing action. This is quite slow for a big part. It's probably been set at the default speed. I might speed it up a bit, because it does a first rapid move to set it approximately, and then a slow move to set it exactly. So the rapid move can be faster than that. See, that's very slow. So now we've set the X. See if I can find on this new version of the software how you set that. So if we go to probe setup, so we can set the probing speeds at the new with this new software. I'm on version V2 5.2. Probe setup. See up here you can set, so I'll just set it at 5,000 and 1,000, and left the fine probe speed low. Well, can we set that any faster? Let's see, at 1500. Okay, we're at 1500 millimeters a minute. So when we want to probe now front to back on the Y, we're just going to use this one here, Y, find center, set origin. So let's see if I can do this. Put a parallel at the back. This will be interesting. I probably won't get there in time with the camera in one hand. One-handed operation. Find center on the Y. Whoa! Just in time. So that's at 1500 millimeters a minute. A bit fast for a camera in one hand. So this a slow final probe that gives you the accuracy. So that's fine. I can change that if I want to. But so I use those two probing routines to find the center. So here again, if you want to change those probing speeds with this new version of the software, you can just put in the values there. So now all the tools are set and the work offset set, so the tools know where the work is, and we can go ahead and run the code. I think that setting procedure is correct. Well, the mechanical tool setter can be set on any surface, and then you set the probe on the reference surface button, and then set the probe length. Then there's a relationship established. But let's just double check. So we'll come back down now with tool number 10 onto a bit of paper, and can I do this with one hand? A little bit more. I think that's it there. That's really just tight now. So my little jar of slips of paper, they're about 0.09 of a millimeter, and under compression maybe slightly less. There we are. Tool 10 showing 0.07 plus, and a plus value, so that's spot on. So setting via that method must be correct, and it was quick and easy. Well, it sounds a bit like I'm preferring mechanical tools over electrical and software, but I'm talking about just finding a Z here, a tool height. With a probe, you're finding X, Y, and Z, and there's all sorts of complicated shapes that you use probing routines for, or finding the middle of a hole or the center of a block or a corner of a block, and a mechanical edge finder is much slower for that type of work. For example, I did a video a couple of years ago, Heimer versus probe, if you're interested, and timed it out and checked on the accuracy of the Heimer versus the probe, and just in time alone, the Heimer took 3 minutes to find the center of a hole versus 36 seconds for a probe using the PathPilot probing routine. So, you know, there's horses for courses. Definitely for work offset setting, a probe is far ahead of a mechanical tool setter. Alright guys, thanks for watching that, and I'll see you next time.